Hello students, the purpose of this video is to get you acquainted with probability, and this is actually set one of your notes. It's going to be part of a three video series. So the main idea of probability is how likely is something to occur. So many events can't be predicted with total certainty. The best way we can say is how likely they are to happen using the idea of probability. So for example, let's assume that we're going to toss a coin. When a coin is tossed, there's two possible outcomes, right? I can flip it and I can get a heads, or I can flip it and I'll get a tails. So we say that the probability of the coin landing on a heads is a half, and the probability of the coin landing on tails is a half, because there's only two options. So there's a 50-50% chance that I'll land on either the heads or on the tails. Throwing a dice. When a single dice is thrown, there are 6 possible outcomes. I could get the number 1, the number 2, the number 3, the number 4, the number 5, or the number 6. So the probability of any of those values ending up being my face value is 1 out of 6. So the probability of event happening, this is like your formula, is equal to the number of ways that it can happen over the total number of outcomes. So in that dice example, going back, the probability of getting a 2 is 1 out of 6 because there's only one side that shows the value 2 out of 6 total different sides. Now, probability is always between the values 0 and 1. So if you're ever solving a problem and you get anything that is a negative value, or you get a larger value other than 1, so you get something like 2 or 3, you know that you've done something incorrectly because it must be between 0 and 1. The closer you are to 1, 1 lets you know, okay, you are absolutely certain that is going to happen. If you get 0, then you are absolutely positive that is not going to happen. And then in the middle, it's kind of like a little temperature gauge going from unlikely all the way to likely the closer you get to the value 1. So, for example, if I have a bag of marbles and all the marbles are blue and yellow, so all the marbles in my bag are blue and yellow, and I say, what's the probability of me pulling out a green marble? You would say, oh, that's impossible because your bag only has blue and yellow in it. So that would be a probability of 0. Whereas if I had a bag that was all blue marbles and I said, what's the probability of pulling out a blue marble? I would say 1 because that's the only color that exists. So of course I'm going to pull out a blue marble. Now, probability is just a guide. It does not tell us exactly what will happen. So, for example, let's say I toss a coin 100 times, how many heads will come up? Well, probability says that heads have half a chance, so we expect about 50 heads, right? About half of those times will be a heads. But when we actually try it, we might end up getting like 48 heads or 55 heads or anything really, but in most cases, it's going to be around 50, and that's called your experimental probability. So as you actually perform an experience in real life, life is going to happen. Life doesn't always work on a formula, and you're not going to get perfect values all the time, and that's okay. But theoretically, by the aspect of what probability is, we have about a half a chance of getting a heads. So some special vocabulary. The very first one is an experiment or trial. It is an action where the result is uncertain. For a sample space, it is all the possible outcomes of an experiment. So for example, when I roll a die, the sample space is the values 1, 2, 3, 4, 5, and 6, because those are the possible outcomes that I could get. Sample point is just one of the possible outcomes. So if I talk about the value 2 on that die, that would be my sample point. And here's an example. So a deck of cards. The 5 of clubs is a sample point because it's a specific card in a pile of 52 cards. The king of hearts is also another example of a sample point. Now, king is not a sample point because there are multiple kings in your deck of cards. So they are each individually 4 different sample points. An event is a single result of an experiment. An example of an event is like getting a tail when you toss a coin. Rolling a 5 on a die would be an event. And an event can include one or more possible outcomes. If I want my event to be choosing a king, well, there's 4 different options. If I want my event to be rolling an even number, I can get 2, 4, or 6 on a die. All of those are considered an event. The sample space is all possible outcomes. Sample point is just one possible outcome, and an event can be one or more of the possible outcomes. So, sample point is like this die that I've pointed an arrow to. The sample space are all of the possibilities that I could come up with, so everything contained in this square box. But then the event has 2 sample points in it, because event A may be, I roll a 5 and a 6. So example 1, what is the probability of choosing a king from a standard deck of playing cards? Well, you need to be familiar with a standard deck of playing cards. There is a total of 52 cards. You have kings, you have queens, and you have jacks. You have the numbers 2 through 10, and then you have the ace cards. And then there are 4 suits, and they are, nope, that's not what they are. They are hearts, diamonds, spades, and I am completely blanking on my other name, and I'm thinking it is the clover, and I am drawing a complete blank on what the name of that shape is. So I am pulling up Google really quick. Sweets in a deck of cards. Clubs. There you go. So the clover shape is a club. So let me put the formal name there. See, it happens to the best of us. We all blank out on things. So clubs. Sorry about that, y'all. So obviously the hearts is a heart shape. A diamond is a diamond shape. The spade is, I always remember it kind of like the upside down heart that has the little stem. And then the club, obviously, I now call that the clover. That's how I always remember it. And it kind of has this sort of shape, if that kind of looks like anything. Okay? So with that being said, what is the probability of choosing a king? Well, I know that there are 4 suits and there are kings in each of those. So there are 4 possibilities. So possibility of getting a king, or probability of getting a king, is 4 out of a total of 52 cards. Okay? Now with probability, people generally ask me, should I round? Is it wise to not round, to simplify? And you definitely can. You're more than welcome to break this down to 1/13. There's nothing wrong with that. I just personally like this answer, 4 out of 52, because it gives me a better idea of how many total items I have and how many out of that total are actually going to be kings. Whereas when I simplify my fraction, it doesn't really give me a good idea of an exact number that I have. Looking at example 2, what's the probability of choosing a green marble from a jar containing 5 red, 6 green, and 4 blue marbles? Clearly today I cannot talk, y'all. Obviously this is why I'm a math instructor and not an English instructor. I don't know what my problem is. I must be tired. So we got 5 red, 6 green, and 4 blue. So 5 red, 6 green, 4 blue, and I want oh my goodness. I should probably just give up and stop making this video. I'm just going to stop talking and write. So what I've written here is the probability of getting a green marble. There are 6 possible green marbles, so I put that in my numerator, out of 15 total marbles in my bag. 6 plus 5 plus 4 gives me 15. And again, this is a good answer. It gives me an idea of exactly what I'm going to have, but if I want to reduce that, I can. And I get 2/5. So I was staying quiet for a second to give you an opportunity to read this problem. What is the probability of choosing a marble that is not blue from a jar containing 5 red, 6 green, and 4 blue marbles? So the probability of not blue. And we actually call this a complement. So another way to notate this is to do blue with a little C. It's kind of like an exponent, but it's a C, and that refers to the complement of blue, which means not blue. There are 5 red and 6 green, so that's 11 marbles that are not blue out of a total of 15. When I look at my example, what is the probability of getting an odd number when rolling a 6-sided die? The options that I have are 1, 2, 3, 4, 5, and 6. And I'm finding the probability that I get an odd number. So that could be this value, or this value. That is 3 out of 6, which is 1/2. What is the probability of choosing a jack or a queen from a standard deck of 52 playing cards? Well, how many jacks are there? There are 4. How many queens are there? There are 4. 4 plus 4 is 8 out of 52 playing cards. What is the probability of landing on an odd number after spinning a spinner with 7 equal sectors numbered 1 through 7? So 1, 2, 3, 4, 5, 6, 7 are all of my options, and I want to land on an odd number. So that is 4 out of 7. What is the probability of getting a 7 after rolling a single die numbered 1 to 6? Well, 7 occurs after 6, so it will never happen. Therefore, the probability is 0 because I'm positive I will never get that solution. What is the probability of choosing a queen, a king, or an ace from a standard deck of playing cards? There are 4 queens, 4 kings, and 4 aces. That's 4 plus 4 plus 4, which is 12 out of 52 total playing cards. What is the probability of choosing the letter L from the word probability? Well, there is 1 L out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. However, we actually need to recount because we're counting letters that repeat twice, and that's not what we should be doing. So this is a unique value, 1, 2, 3, 4, 5. Skipping B because I've already counted that. 6, 7, skipping the I, 8, 9. So actually 1 out of 9 because there's only 9 unique letters in that word. What is the sample space for choosing a letter from the word probability? Well, we just talked about that. Our sample space is the letters P, R, O, B, A, I, L, T, and Y. As always, I hope you found this video helpful. If you have any questions or concerns, please don't hesitate to reach out.